All right. So far, the datum of interest is chosen first, and then one is tasked to calculate a percentile rank second. So you can see here in this table, this is the same data set that we've been working with in the previous examples and think pair shares. And so far, every time, you were told to calculate the percentile rank given a datum of interest. So starting with the datum of interest, calculate a percentile rank. Starting with a datum of interest, calculate a percentile rank. Starting with a datum of interest, calculate a percentile rank. So we've been given a datum first to start from, and then calculating the percentile rank of that second. But now we're going to be doing things in reverse. Now you're going to be starting from a percentile rank and calculating a datum of interest associated with it. So we're going to be going in the opposite direction. Okay, so now reverse the problem. First, a percentile rank is chosen, and then one is tasked to calculate the datum of interest second. So for example, let's say we were given the percentile rank of a datum of interest was 30. So we look here at this table and we look at our percentile ranks. Here we've got a percentile rank of 17. Here we've got one of 41. So a percentile rank of 30 is going to be between 17 and 41. All right, so we know 30 is going to be somewhere in this range. So what would be some datum of interests related to this percentile rank of 30? Well, as we look up at the actual datums themselves, it's just 73. It doesn't matter if the percentile rank of 30 was here, or if it was somewhere in between, or if it was here. The related datum of interest is just going to be 73 no matter what. Okay. But it's not always going to be this straightforward most of the time. So what we need is a formal method to calculate a datum of interest when a percentile rank is chosen or is given. The datum of interest is related to a chosen percentile rank, and this is called a kth percentile, or abbreviated pK. So let's look at the definition of the kth percentile. So the kth percentile is the datum of interest given a certain percentile rank. The kth percentile is going to be a number between the minimum and the maximum datums of the data set. So the kth percentile that we calculate will be less than or equal to the maximum and greater than or equal to the minimum. So it's going to be somewhere in the middle of your data set somewhere. So the kth percentile is where k% of the datums are less than a value of your kth percentile. And here's an important note. The kth percentile does not have to be a datum value in the data set. And I'll allude to that later when we do some examples. So in order to calculate the kth percentile, there's going to be two steps with three known variables. So the first known variable is going to be your data set itself. The second known variable is n, which is the total count of datums in your data set. And you're also going to know what the percentile rank is. So step one is to calculate the rank of the datum of interest. So the rank for the datum of interest is going to be equal to this lowercase k times n plus 1. So off to the right, I've defined what all of these mean. So R subscript DOI, this is the rank of the datum of interest related to K. Lowercase k is just the percentile rank divided by 100. And n, like we saw before, is just the total count of datums. Now, an important note is that this part of the formula, k times n plus 1, when that is simplified, it's going to come down to a single number that may or may not have a decimal point in it. And we're going to need to pay attention to whether it has a decimal in it or not. The part to the left of the decimal point, we're going to call that the integer part. And the part of this simplified value to the right of the decimal point is going to be what we call the decimal part. So for example, if we had used this formula and we calculated the rank of our data of interest to be 14.0, then that means the integer part is 14. So the integer part is 14, and the decimal part is 0. The decimal part is 0. In another example, if we had calculated the rank of our datum of interest to be 29.25, then the integer part would be 29, and the decimal part would be 0.25. All right, so this is, kind of the formula that you want to use and the outcome from that formula that you want to carry into step 2. So step 2 is to calculate the kth percentile. And so depending on this value of the decimal part, whether it's equal to 0 or it's not equal to 0, is going to determine what formula you use down below. So if the decimal part is 0, then the kth percentile is just going to be the datum with the rank of the integer part up above. If the decimal part was not equal to 0, you're going to use a weighted average method, and that uses this formula here. And really, those are the two conditions you need to pay attention for. This other formula that I have here on the right-hand side, this is just showing you the formula that the Texas Instruments and the NumWorks calculators use when calculating quartiles, and we'll kind of get into that later. And because this is how your calculator calculates quartiles, don't worry about using this formula if you're being asked to calculate quartiles. Okay, but we'll kind of get into that. Take a look at this note later. It's not going to mean a lot right now, but let's actually now start to look at a few examples to try and make sense of this two-step process. Again, there's only 2 steps, and it looks really complicated right now, but I think as you see it unfold in an example, it's not going to look that bad.